All right, in lesson 51, we did a nice little activity in class where we learned how to name the sides of a right triangle, opposite, adjacent, and hypotenuse. It's very important to know which one's which. Of course, we know the hypotenuse by now. It's just a matter of which one's the opposite, which one's the adjacent. It's all based on the angle. And then we found these ratios that hold for looking at the relationship between the sides and the angle of a right triangle. So we talked about that, and we actually named them sine, cosine, and tangent. Well, what we're going to do in this lesson is we're going to go a little further, and we're actually going to learn how to find an angle or find a missing side of a triangle using sine, cosine, and tangent. So the first thing we're going to do here is we're going to recall and review what we did yesterday, naming the sides. So number one, what is the side opposite angle A? So I want you to take a second and see if you can do that. Here's angle A right here. Which side would you consider to be opposite of that side? So basically what you could do for opposite is you could just draw an arrow right from that angle, right out. Draw an arrow, and what side do you hit? You hit this side right here. So BC is the opposite side of angle A, All right? What is the hypotenuse? The hypotenuse is always opposite of the right angle. So if you find your right angle, which is right here, and just draw an arrow from there, what side do you hit? You hit AC. So AC is going to be my hypotenuse. And then the adjacent side is like the leftover side, or the side that's next to the angle. So here's, adjacent means next to. So here's angle C. Whatever leg is next to that angle, so that's AC. Okay? AC is the hypotenuse. I'm sorry, it's not AC, because AC is the hypotenuse. So this is my hypotenuse. And then if I go opposite, right, this is my opposite right here. So what's my adjacent? It's the one that's left over. You can do it like that, or you could say, all right, what leg is next to the angle? Well, here's the leg, CB, that's connected to the angle C, which is the angle we're referencing. All right, so it is going to be CB. CB is going to be our adjacent side if we're talking about angle C. All right. So if we look at the ratios of the sides of a 30, 60, 90 triangle, we need to identify which angles we're referring to. In the example below example, we will refer to the sides based on the reference angle of 30. So here's 30, and then you got your opposite leg, and there's your adjacent leg, and there's your hypotenuse. Now this is based on a 30-degree angle, and you might be saying, well, where are these coming from? Well, this was something that I kind of skipped over, a lesson I skipped over, because we're going to kind of handle it in this lesson anyways. So we're not going to really spend too much time on this. This is going to make more sense after we do the actual lesson. So rather than spending a lot of time and wasting time on the video here, I'm going to skip over this part here. But I want to show you that what happens is we get these ratios that we did in the activity yesterday. When we did opposite over hypotenuse, we got a certain ratio. When we did adjacent over hypotenuse, we got a certain ratio. Yesterday, remember we did a 30-degree angle, we came up with 0.5. It always was 0.5, or right around 0.5. Depending on the measurement, we're using a ruler, right? So it may not be exactly 0.5, but it's around 0.5. The adjacent hypotenuse is right around 0.866. When you do adjacent over hypotenuse, we found that out yesterday. And then when we did the opposite over adjacent, the tangent, that came out to be 0.5774. So that is these ratios, and it's not just for a 30-degree angle. We can do this for any angle. These ratios that come about are the basis for trigonometry. And the trigonometry is the study of the measurements of sides and angles in triangles. That's what trigonometry is. Study of triangle measure. So we saw this yesterday. We saw sine, cosine, and tangent, and all these crazy ratios. That's like, whoa, just looks like a bunch of numbers if you just look at it, right? Just looks like a bunch of numbers. We're going to learn how to use this table today to actually make sense and what we're going to use. We're going to learn what this table is actually used for and how we can use it. Because basically what it is if you know the angle measure, then you know the ratios. These are the ratios. So I'm going to pick example, a 20-degree angle. Okay, 20-degree angle. If I know I have a 20-degree angle, I know that the opposite over hypotenuse ratio is going to be 0.3420. I don't know necessarily how big the opposite and hypotenuse is, but if I know the opposite, I can find the hypotenuse. If I know the hypotenuse, I can find the opposite. If I know I have a 20-degree angle and I know cosine is 0.9397, that means the ratio has to be 0.9397. When you divide the top by the bottom, you got to get 0.9397. Adjacent over hypotenuse is 0.9397. If I know the adjacent, I can find the hypotenuse, and so on and so forth. And that's true for any angle. And then here's all the ratios. They're all just turned into decimals. You know, ratio is a fraction usually, but you just turn it into a decimal. So what we're going to do is use this table, and here's a little chunk of the table right here just because it's focusing in on what this example is doing. That's going to help us. But anyways, here is example 1, knowing sides get angles, knowing angles get sides. So first thing is, here's a triangle, okay? I don't know the angle. If I don't know the angle, I can get the angle by knowing the sides, because this side right here is the opposite and this is my adjacent side. So I know I'm going to use the tangent function. If those are the two sides I know I'm going to use tangent. So tangent is 2.62 over 2.2. Now, that's in fraction form. I want to convert it to this form right here, so I want just a decimal form. So what I'm going to do is divide 2.62 divided by 2.2, and I come out to get 1.191. So now I have to go to my table under tangent, and I have to look for 1.191. And the closest I can get is right here. I've already highlighted it. And if you go over, it says 50 degrees. So if the tangent, because we did opposite over adjacent, if that's 1.191, then I know that my angle must be 50 degrees using the chart. All right, so I know, so what I'm doing here is I'm actually doing tangent inverse, tangent raised to the negative 1 of 1.191, and that is approximately 50 degrees. So I know theta is approximately 50 degrees. Again, I knew the tangent, so I know the angle. I just got to use the chart to get the angle. Okay, this is according to the trig table. This is called a trig table. Okay, so according to the trig table, if I have a tangent of, like I said, 1.191, the angle must be 50. Now, if I know the angle, so for this one here, all I know is the angle. I could find opposite hypotenuse if I knew one of them. I don't know either one. All I'm asking you to do here is figure out what's the sign if the angle is 54. So if the angle is 54, I'm going to go to my trig table. Where's 54? Where's 54? Right here. Okay, so we're not looking at this anymore. What's 54? What's the sign going to be? What's the opposite over hypotenuse going to be for 54? I just go over here, I look under sign, and there it is, 0.8090. So approximately, let's just say approximately, 0.8090. So now that doesn't give me the opposite or hypotenuse, it just gives me the ratio of opposite over hypotenuse. So now if I know the opposite, I could find the hypotenuse. If I know the hypotenuse, I could find the opposite. And that's what we're going to be doing in examples 2 and 3. So in example 2, we're going to find the missing angle. The missing angle, okay? So the first one's already set up for us, tangent. How do I know it's tangent? Because here's the angle, theta, and I know my opposite, and I know my adjacent. 13 and 34 are the opposite and adjacent. It may help, you may want to label the sides before you do anything, and that's going to help you determine which trig function you want to use. See, I don't know the hypotenuse, so I can't use cosine or sine because it needs the hypotenuse. Tangent uses just opposite and adjacent. So now tangent, theta, so we're just going to fill in what we know. Tangent theta equals opposite, which is 13, over adjacent, which is 34. So let's divide that. And I did this ahead of time just to save us time, because if I had to type this all in, or if you had to type it in, we would just be wasting time. 13 divided by 34 is 0.3824. 0.3824. Okay, so now what we have to do is we have to go to our table. And we have to do inverse tangent 0.3824. That means we got to look under the tangent column. We got to look under the tangent column for 0.3824. So I'm going to do that. Tangent column, right? Here's the tangent column. And we got to look for 0.3824. 0.3824. 0.3824. Well, the closest I can get is 0.3839. And if you look, that is 21 degrees. So I know 21 degrees is the closest I can get using my trig chart. 21 degrees is as close as I can get. So I know that theta is approximately 21 degrees. Okay? This one here, here's my theta. All right, here's my opposite. And I don't know the opposite, so I'm not using opposite. Here's my hypotenuse, that's my longest side. That's across from the right angle. And here's my adjacent. So we're not going to use opposite because I don't know it. I know adjacent and I know hypotenuse. So which of my trig functions is adjacent hypotenuse? Well, adjacent over hypotenuse is cosine. So this one's going to be cosine theta equals adjacent over hypotenuse. So this is going to be cosine theta equals 25 over 32, which is approximately 25 over 32 is 0.7812. 0.7812. So we're going to we're looking under the cosine column now, and we're looking for a 0.7812 ratio. Cosine 0.7812. Get rid of that. Oop. Come on. Cosine 0.7812. 0.7812. Come on, stop that. 0.7812. Looks like right here. Okay, so about 38 degrees is going to be as close as we can get using our trig table. Okay, so cosine inverse, all right, cosine inverse 0.7812 we said was approximately 39 degrees. Okay, and that's approximately theta. Oops, theta. All right, we did say 39, right? 38. 7812. Oh, actually 7812 is closer to, sorry about that. It's a little bit closer to 0.77. This is aggravating. I can't get this to go down. Sorry, guys. All right, so it's actually a little bit closer to 0.7771. I messed that up. It's a little bit closer to 0.7771 than it is to 0.7880. So it's going to actually be 39 degrees. 39 degrees for theta. All right. And then this one here, we have opposite, and this is opposite, and this is my hypotenuse. So that's opposite hypotenuse is going to be sine. Sine theta equals 22 over 34. Opposite over hypotenuse. Okay? And that's approximately 0.6471. 0.6471. All right, so we're going to our table and looking for sine 0.6471. Sine 0.6471 is going to be right about here, and that's going to be 40 degrees. Closest we can get is 40 degrees. So we know our theta is going to be approximately 40 degrees right there. Okay? And then our last example is going to be finding sides. All right, so now we know the angle, now we want to find the side. So watch how this works. So again, what side do we want to find? We want to find the opposite. This is opposite. And this is adjacent. So we're given adjacent and we want to find opposite. That's why we have to use tangent. So it's going to be tangent theta, which is 38. So you're going to say tan 38 equals opposite, which is x, over adjacent, which is 12. So now the x is in a different spot. That's okay. Put this over 1 and cross multiply. 1 times x is just x. X equals 12 times tangent 38. Okay, 12 times tangent 38. Now, tangent 38 we can get from our table. So it's going to be times tan 38. Just go to your table. Tan 38 is, get rid of all this, tan 38 is right here, 0.7813. Okay, 0.7813, 0.7813. And if I do 12 times 0.7813, I did that ahead of time to save time. It's on this page here. And that's going to be 9.38. And that's all just calculator work right there. Okay, approximately 9.38. All right, this one here, the angle is 16. The opposite is 8. And this is the hypotenuse. This is opposite. This is hypotenuse. Okay, that we're trying to find. So that needs to be sine. Sine 16 equals opposite, which is 8, over hypotenuse, which is x. This time the x is on the bottom. That's okay. So cross multiply. X times the sine of 16 degrees equals 8 times 1, which is 8. So again, just cross multiply like any other proportion, and then divide by the sine of 16. Divide by sine 16. Now we got to figure out what sine of 16 is. That cancels, right? So it's just going to be x equals 8 over the sine of 16. Now look it up in the chart. I did it already just to save time. It's 0.2756. 0.2756. And then, of course, you just do 8 divided by 0.2756, and x is going to be approximately 29.02. Okay, 29.02. Again, that came from your chart. On the sine table, just go down and look for 0.2756. Or, I'm sorry, look for 16. And then under sine, it's 0.2756. This one here, here's the angle. This is adjacent hypotenuse. Adjacent and hypotenuse. So this is 55. So we're doing a cosine now. Cosine 55, because it's adjacent hypotenuse, that's why it's cosine, equals x over 18. Put that over 1, cross multiply. X equals 18 times cos 55. Okay, and we're going to do 18 times, now the cosine of 55, again, go to your table, go to 55 degrees, go to cosine, look down, and you should see 0.5736. Just did this ahead of time so I don't keep flipping back and forth. Save you guys a little bit of time here. 18 times 0.5736 is 10.32. So we would know that that x, that adjacent side, is approximately 10.32. We will work on this the next 2 days in class. We're going to practice this until we get really good at it, because then we're going to do go on and from there. We can't move on until we get really good at these relationships. See you then.